Hello, welcome to the video lesson, or video notes for lesson 5-7. This begins on page 35 in your notes section in your binder. And this lesson is about the y-intercept of a line, initial value. So you'll remember from the last lesson we learned about initial value and what that means. Essentially, the key idea is to remember initial value is what we're really talking about is when the input which is also the x value is equal to 0. Okay? So our target for this is I can identify the y-intercept of an equation, table, and graph. So no matter which model or which form of a linear function that you're looking at, you should be able to spot the y-intercept or the initial value. Okay? Alright, so first example we have. Graph each equation on the graph. What is the same, what is different? Alright, so the first thing we're going to tackle is we're going to graph these, okay? So I have these tables, and you'll notice they give us the equation and they give us our input values, and we got to figure out the output values that go with it. So I'm going to extend it and do 2x. So here I've got, actually I should have extended it here and do 2x. So the first output value is going to be 2 times negative 3, and 2 times negative 3 is negative 6. And then I'm going to do 2 times negative 1, 2 times 0, 2 times 1, and then 2 times 3. And I get negative 2, 0, 2, and 6. Over here, I've got a very similar equation. This time it's going to be 2x plus 4. So I'll think about, and I've got the same input values. So what is negative 6 plus 4? That's negative 2. What is negative 2 plus 4? That's positive 2. 0 plus 4. If you're wondering where I'm getting these values from right here, they're all coming from this right here because it's right next door, and I already know what 2 times those input values are. Alright, so then I've got 4, and then I should have 6, and then 6 plus 4 is 10. Okay? And then one more time, this time I'm going to be doing 2x minus 3. So going back to these, and I'm using the same input values, so 2 times negative 3 is negative 6, minus 3, that's negative 9. Then I've got negative 2 minus 3, that's negative 5, 0 minus 3, 2 minus 3, and 6 minus 3. And then my values here are negative 3, negative 1, and then 3. Alright, so now I have 3 tables. I am going to plot them on the graph below. Oops, I got chopped in half. So I'm going to have to slide this up. We're not going to be able to see the tables anymore. That's okay. Alright, so the first table, this table here, I'm going to plot with red. So that is, the input is negative 3, the output is negative 6. So I'll put a point there. Let's see here, 1, 2, 3, 4, 5, 6. The next one is negative 1, and then negative 2. And then the next one is 0, 0. And then I have 1, 2, and then 3 and 6. Okay, Then I want to connect them with a nice straight line. So I'll use my line tool, and it should actually have arrows on both ends. And it looks like that. Okay, next I'm going to plot using blue, and that's going to be table 2, the one in the middle. So I've got -3 and then -2. I've got -1, +2. I've got 0, 4. I've got 1, 6. And then the last one is 3, and that's at 10. So again, I'll use my line tool, draw a nice perfectly straight line going right through my points. Alright, and the last one, I'm going to graph using green. If you've got different colors, it just helps to keep things separated. So this table, I've got -3, -9, that's down here. Then I've got -1, -5. Then I have 0, -3. 1, -1. And then the last point is 3 and +3. And I'll connect that again using my line tool one last time. Then we've got our questions we can answer. So, first question is, what is the same? Well, if you look, I think I might have messed this last one up a little bit, but if you look closely, these lines all have the same steepness. So, all 3 have the same steepness, which is also known as, well, same steepness. They should look parallel. And basically what that means is they have the same slope, and if I were to find change in y over change in x, I would get 2 over 1, or 2, which is their slope. Alright, so what do they have different? Well, if I look at each graph, here, here, and here is where they are different. What that is called is the y-intercept. So the y-intercepts are different. And you can see for line 1, the red one, so let me do this in red. Line 1, it's here, and it's 0, 0. And you can see that in the table too. For line 2, it's right here, and it's 0, 4. And for line 3, that's right here, it's 0, -3. Oops. Now, if you look in the table, you should actually be able to see these same 3 points. So let me go back to that. They are all right here, where the input value is 0. And then if you look in the equations, well, this one and this one are easy to see. Here, there's nothing. What that means is it's really +0. So that's the y-intercept values. Okay? Alright, so we can see some more examples of this on the next page, page 36. So let's go ahead and take a look at that. Okay, key concept. The y-intercept of a graph is the y value at which the graph crosses the y-axis, or when x equals 0, or when input equals 0. Alright, so if I'm looking at this graph here, it's right there where the line crosses the y-axis. It's 0, 0. If I look at this one, it's right there. I figure out what the value is when x is equal to 0, and it's 4. And this one here, I figure out what the y value is when x is equal to 0, and it's negative 3. Alright? Okay, we've got 3 more examples at the bottom that are in the different forms. So we have, what is the y-intercept? So, when you have an equation, you can look and spot it right there. But another way to do this is say, well, okay, when x equals 0, what is y? Alright, so y equals 2 times 0 minus 5. What is 2 times 0? It is 0 minus 5, and 0 minus 5 is negative 5. So, there is one way to answer this, or you can describe it as a point, which is 0, comma, negative 5. I think putting it as a point probably is the best way to answer this, because if you think about a graph or a table, so graph is pretty simple. You just look with your eyes. Where does it cross the y-axis? At the point 0, 1. And then on a table, again, you look for where the input value or the x value is 0, and you have 0, comma, 6. Alright? So that's how you find y-intercept, also known as initial value. It's when x is equal to 0. Bonus question. Y equals 1/2 x. If you can tell me, or if someone can tell me, the slope and the y-intercept for this equation, I'll give you 2 points for each of those. However, it's got to be a different person for each one. Alright? If you have any questions, go back and rewatch the video, ask a friend or an adult for help, or come and see me. Good luck, and we will see you in math.